Teach me.
Hello everyone, it's me Arvind catching you on another Math Tutor Edu's lecture video. Okay, in this lecture video, we are discussing a new subtopic within the chapter quadratic functions, which is the types of roots of quadratic equations. Okay, so without further ado, let us start our discussion. Okay, in order to identify the types of roots of quadratic equations, let us take a look at the recap of the quadratic formula, shall we? Okay, so in this chapter, we also learn about the quadratic formula. So what is the quadratic formula? Okay, it is given that x is equals to negative b plus minus square root b square minus 4ac, okay, and then you divide with 2a. Okay, let me underline the square root line and the fraction as well, okay, before I missed out. So let me underline the fraction line as well. Okay, in case if you don't know what is this is actually the quadratic formula. Okay, if you take a look inside the square root, you have the b square minus 4ac. This b square minus 4ac is known as the discriminant. Okay, this discriminant is going to be useful for us in order to identify the types of roots of quadratic equations. Okay, so this b square minus 4ac, the other name is also known as the discriminant. Okay, so there are three types of discriminant that we are going to learn in the types of roots of quadratic equations. Okay, so we're going to take a look at them one by one. Okay, so in this subtopic, our main concern is the b square minus 4ac. This expression. Okay, so basically what we are doing is we are taking a chunk of the equation from the quadratic formula and it becomes the discriminant b square minus 4ac. Okay, this discriminant I'm going to further explain you. Okay, there are three types of discriminant, guys. Okay, so let us start with one by one. Okay, so whenever your b square minus 4ac becomes more than 0, okay, so it has its own condition, guys. Okay, you have three types of discriminant and each discriminant has their own condition. Okay, when your b square minus 4ac more than 0, okay, that means you have two distinct roots. Two distinct roots. Okay, that means you have two real and distinct root, means that means the roots are real. Okay, you, for example, 2, 5, 1.35, negative 5.34, they are real roots. Okay, so these are the condition. Okay, when your b square minus 4ac more than 0. Okay, how about when your b square minus 4ac equals to 0. Okay, when your b square minus 4ac equals to 0, okay, you will have two equal roots. Equal roots, or sometimes you can even address as one root also can. Okay, it's either one root or two equal roots. Okay, that means two roots, the value are the same. That's why sometimes you address it as one root. You can even address as two equal roots also can. Okay, so this is the expression for b square minus 4ac equals to 0. Okay, you have more than 0, equals to 0. How about less than 0? Okay, so we're going to take a look at it now. Okay, when your discriminant b square minus 4ac becomes less than 0, okay, you do not have any roots. That means that there is no real roots. There will be no roots. That is why you have no real roots. Okay, that's why here you have no real roots. Okay, so this is the concept that you're going to learn in this type of roots of quadratic equation. Okay, you have three types. Okay, when your b square minus 4ac more than 0, we have two distinct roots. Okay, when your b square minus 4ac equals to 0, you have two equal roots, or sometimes we can call it as one root. Okay, but then when your b square minus 4ac becomes less than 0, you have no real roots. Okay, why no real roots? Okay, let's say for example, here you have a negative 5. Okay, when you try to square root the value negative 5, for your level, you will not have any solutions. Okay, that is why you have no real roots. Okay, only these two solutions are possible. For this, you will not have any roots. Okay, enough with the explanation. Now I'm going to discuss with some examples. Okay, so let us start with the first example. Okay, so let me read the example here. Find the value of p if the quadratic equation 4x square minus in a bracket 4 plus p bracket x plus p equals to 0 has real and equal roots. Okay, so these are the question that we're going to solve. Okay, let us solve this question together. So to start off, let me write the whole expression. Okay, so just write here example 1. Okay, so from here 4x square minus k in a bracket 4 plus p close bracket x plus p equals to 0. Okay, the first step what we're going to do is we're going to identify the coefficient of a, b and c respectively, since this obeys the quadratic equation respectively. Okay, so from here we can identify the coefficient a is actually 4. Okay, the coefficient b is equal to negative in a bracket 4 plus p. Okay, negative in a bracket 4 plus p. Okay, whereas your coefficient c is equals to p itself. Okay, so from here the question gave us the condition has real and equal roots. Real and equal roots means, that means your b square minus 4ac equals to 0. Okay, so once you identify the condition and you write down the equation, okay, the rest is all the matter of working, guys. Okay, so now what you do, you substitute the coefficient value into this equation respectively. Okay, so from here, okay, negative in a bracket 4 plus p, okay, square bracket square minus 4 times with coefficient a 4, okay, times with the coefficient c, in this case is p, okay, equals to 0. Okay, let us do the working for this. So continue, so it will be negative 4 minus p square. Okay, we solve the inside bracket first. Okay, and then minus, okay, negative 4 times with 4, it will get is negative 16. Negative 16 times with p will be negative 16p equals to 0. Okay, so now what we're going to do, we're going to expand this bracket. So from here we expand this bracket, so from here you get is 16. Okay, and then negative 4 times with negative p, you get is 4p, and then you times with 2, so from here you get is positive 8p. Okay, negative p, okay, you square it, you get is positive p square. Okay, and then minus 16p equals to 0. Okay, now you can see that we are literally forming a quadratic equation. Okay, so from here p square, okay, so 8p minus 16p, so from here you get is minus 8p. Okay, and then here you plus with 16 equals to 0. Okay, so let us solve this. Okay, let us perform the factorization. Okay, so from here p minus P minus K. So let us perform the calculation. Okay, let me just key in the calculator. Okay, number 3. Okay, our coefficient A is 1, coefficient B is negative 8, coefficient C is 16. Okay, so from here you only get one value, which is x equals to 4. Okay, so from here, since you get only one value, okay, it will be P minus 4 times with P minus 4. Okay, you only get this equals to 0. Okay, you can write in this way, or you can write in this way as well. P minus 4 square is equals to 0. You can write like this also can. Okay, so from here, therefore you can only have one possible value. In this case, your P is equals to 4. Okay, remember that I said that when you have b square minus 4ac equals to 0, you have either one root or two equal roots. Okay, it's obey the same thing here. To find the condition of real and equal roots, you come up with the real and equal roots itself. Okay, what a coincidence, guys. Okay, so from here you only have one root over here, which is in this case P is equals to 4. Okay, let me underline this solution. Okay, so let me solve one more question. Okay, let me read the question now. Find the range of values of q if the quadratic equation x square minus qx plus q plus 3 does not have real roots. Okay, in this case now they are asking for the real roots. Okay, the working is still the same. So let me solve this together. Okay, the same step. Step number 1, write down the quadratic equation. So from here, x square minus qx plus q plus 3 equals to 0. Okay, so identify the coefficient a, b and c respectively. So from here, your coefficient a is equals to 1. Okay, your coefficient b is equals to negative q. Your coefficient c is equals to q plus 3. Okay, since in the question they gave us the condition that does not have real roots, so from here you're going to apply b square minus 4ac less than 0. Okay, so let me box this. Okay, the next step, it is very straightforward. So what you do, you substitute the respective coefficient into the equation over here. Okay, so from here, let us solve this together. So from here, negative q square minus 4 times with the coefficient a, in this case is 1, okay, c in this case is q plus 3 less than 0. Okay, so from here, negative q square you get is q square. Okay, so from here, okay, negative 4, okay, and then times with q plus 3, okay, you get is negative 4q minus 12, okay, less than 0. Okay, so from here, q minus q plus. Okay, so from here it will be q minus 6 and then q plus 2. Okay, let me double check. All right, less than 0. Okay, so from here, Remember that we have learned the quadratic inequalities concept. Okay, that the concept you're going to apply over here since it is less than 0. Okay, so what you can do is you can sketch a graph. Okay, so let me just do it quickly. So sketch a quick quadratic graph. Okay, so you include the roots here. So here will be -2 and 6. Okay, and you shade the region under here since it indicating less than 0. Okay, so from here your final answer will be -2 less than q less than 6. Okay, so this will be your answer. Okay, so that is all for the lecture video for today. So I hope you understand the concept and the examples that I've explained to you. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.
I'm out of here.